Okay, hi everybody. We have lesson number 5 today. I'm going to go through this very briefly. This is a major, big time review of geometry stuff. For a lot of you, geometry was maybe 2 or 3 years ago, okay? And so there's probably a lot of things that are kind of simple, but you might have completely forgotten about. So just allow me to briefly refresh your memory on some stuff that this lesson is going to cover. If I go too fast, go ahead and pause. And also remember, I'm just trying to explain how to quickly get each of these answers that I already have filled out here. If I go too fast, if you feel like you need more of an individual refresher, if you have specific questions, you guys remember that's what Optional Fridays are for, okay? Come in and see us and let us help you understand this lesson a little bit better. But here's your brief synopsis, okay? In a triangle, you remember that the 3 angles in a triangle always add up to 180. Vertical angles, here's an example. See these two 60s? Anytime 2 lines cross, they make vertical angles that are equal. That's a fancy word for, or congruent is a fancy word for equal. We have a linear pair, so that's 2 angles that form a straight line, and therefore a straight line is always 180 degrees. And then remember your trig ratios. Towards the end of this lesson, I'll do a couple SOHCAHTOA problems. What does this mean again? SOHCAHTOA. S stands for sine, C stands for cosine, T stands for tangent. Those are 3 buttons on your scientific calculator. And what are the ratios that go with those? Well, sine is the opposite side divided by the hypotenuse. I will refresh your memory on what opposite, adjacent, and hypotenuse, what those mean when I get to a right triangle at the end of this lesson, okay? But those are your trig ratios also. Let's dive into number 1. And so as you can see, I do have several things that are already kind of filled out in this picture. But looking at this figure above, I'm plugging in 100 for x. That's the first thing I did. The x is right here, which means that's 100 degrees. And remember, I have a triangle right here, and I was given 100 degrees is where x is. I was given the 20 degrees in the picture also. So if I subtract those 2 from 180, that is how I got this 60 right here. Okay. A lot of times it might be helpful to fill in every single angle in a picture and then try and figure out what the question's asking for. But anyways, once we get 60 here, remember vertical angles, that means 60 is right there also. I have 2 lines here that are intersecting, and that means that those 2 60-degree angles, this one and this one, are equal. Okay, and now let's look at this triangle right here. We have a 40-degree down here at E. And I also know that this one is 60. That adds up to 100 degrees. And I know that in any triangle, I'm supposed to have 180 degrees. That's why I subtracted from 180 and I figured out what y was. And that is the right answer, and that is what the question was asking for, which is y. Here's kind of a similar question where there's a bunch of different vertical, or a bunch of, pairs of vertical angles and linear pairs. And intersecting lines like so. And we have to take x, which is 65, and plug it in right here. And notice how I have some vertical angles here. So I put 65, which means this is also 65. I filled that one in right away. I think that the vertical angles will probably help me in this case. Another thing that they told us was that y was 75. So again, I have 75 right here. And because of the vertical angles, I put a 75 here also. Okay, so now the only 2 things that I'm missing are these vertical angles right here, and I can figure out that if I take this angle and this angle together and I smush them all together, because I have a straight line here, I should be able to figure out that Z is 40. And again, because of vertical angles, I decided to put the 40 here also. But that was what the question was asking me about, which was Z. And as long as you fill in all your vertical angles, you should be able to figure that one out pretty quickly. Let's look at this question. So this is interesting because we have some parallel lines right here. Oops, that was my eraser. We have parallel lines. How did I know that? Because it tells me in the wording of the question. And you guys have to remember, you did an entire chapter in geometry class about parallel lines cut by a transversal and how that creates all kinds of like angle pairs, okay? So the first thing I'm noticing, and I wrote it out there off to the left in blue, same side interiors are supplementary. If you can look at this, even though it tells us the figure's not drawn to scale, this looks like an obtuse angle, and this one looks like an acute angle, and these are called same side interiors because they are inside the parallel lines. and they are on the left-hand side of the transversal, which is line K. They're both on the left, and same side interiors are sup. I don't know if you memorized the S's when you were in geometry, same side sup, but that's how I figured out what angle A was. And I noticed there's also an angle A right here, so that's awesome. If this is 50, this is also 50. That might be helpful. We are trying to figure out what angle B is, and now going back to something that we talked about on the previous page, if I know that this is 50 right here, and here's a right angle because this is a right angle, then look, I have a triangle. Oh, sweet. And in a triangle, I know that all three angles add up to 180 degrees. So if A is 50, this is 90, you can subtract and you can figure out that we get 40 degrees for angle B. Okay, we've got another triangle here, and I just, without even thinking about anything, noticed that we had two of the angles, the 70 and the 50, so therefore I subtracted from 180 and I got 60 right here. And I'm noticing that I have a straight line right here, and so if part of the angle for the straight angle is 60, then that means that the other part is 120, and that's how I got this angle right here. Look at this straight line. A straight line has 180 degrees in it. And if this right here is 60, that means that I just do 180 minus 60, and I get 120 for x. I do want to remind you of something called the triangle exterior angle theorem. This angle right here is on the outside of this triangle. Would you agree? It is an exterior angle. And what's kind of cool, if you remember this property from geometry, is that this angle right here, which is on the outside of the triangle, is equal to not the one that it is a linear pair with. I'm going to cross that out, but this one plus this one together. Isn't that kind of cool? The exterior angle, this one, on the outside of the triangle, is equal to, skip this one, these two added together. 70 and 50 equals 120. It's called the exterior angle theorem. It's called the two remote interiors. Remote means like not touching this angle. It's the other two angles of the triangle, which is kind of cool. Either way you look at it, you guys, you get 120 degrees. Lots of geometry here. Here we are back to the parallel lines. We have these two parallel lines cut by a transversal, and you did a ton of problems in geometry about this. If you know one of the angles, the 110 right here, you actually know all 8 of them in this picture, okay? Notice how I'm putting the 110 right here and right there because they're vertical. And I also have a straight line right here, which I know adds up to 180 degrees. Therefore, I know if this is 110, I could find this one by subtracting from 180. And then once you know this one, you know this one because, hey, we've got vertical angles again, remember? The intersecting lines make vertical angles. Anyways, you can also copy paste these 4 and put them up here. And so therefore I wrote a 70 right next to x, and that is how I knew x was 70. One of the things that I teach my students when we're doing this chapter in geometry class is that unless all these angles are 90 degrees, they should always alternate. You should never have any two angles that are the exact same right next to each other, but notice how they're always alternating. 110, 70, 110, 70, 110, 70, 110, 70. Cool? And how do I figure out what the missing angle is? If I know one of them is 110, the other 4 are whatever 180 minus 110 is, which gives you 70. So you can always figure out all 8 of the angles very quickly. Okay, now we're getting into our SOHCAHTOA questions. So just like I refreshed your memory on the trig ratios. What I want to first remind you how to do when we're doing SOHCAHTOA stuff is that they will always tell you what angle you're referencing. We're talking about angle A in this case, which is why I put a swoop on angle A. So this is the angle that the question is asking about. And regarding angle A, I want to label the opposite, the adjacent, the hypotenuse. How do I do that? Well, the opposite means opposite of angle A. So the side that is opposite angle A or across from is going to be labeled opposite because we're talking about angle A. Now, if we were talking about angle B, that would be a different situation, okay? Because this would no longer be the opposite side. But that's why it's important to swoop the angle in question. The one that we're talking about is A, and the side opposite angle A is this one. So that's why I labeled the 20 opposite. Adjacent means right next to. So this one right here, that the side that is touching angle A is adjacent. And how did I know that this one was hypotenuse? Well, do you remember the vocab word hypotenuse is always across from the right angle? So find the right angle. And no matter what, this side right here is always the hypotenuse. And also the hypotenuse is always the longest side in a right triangle. So once you have this labeled, it's very, very simple if you can remember the ratio for SOHCAHTOA. S for sine, OH, so. That's what you wrote on the first page. You can flip back if you need to. But the opposite side I labeled was 20. That's why I put 20 on top. And the hypotenuse side right here is 29. So 20 over 29 is our ratio for sine, okay? One thing that you need to keep in mind is that sometimes this fraction right here will reduce, and these answers will always be written in reduced form. So 20 over 29 does not reduce. That's why that was the answer, but beware that the fraction might reduce, and all of these answer choices will likely be the reduced fraction. Keep that in mind, okay. How about this one? We've got tangent. Okay, so tan is opposite over adjacent. Flip back to the first page. That's the ratio for tangent that you wrote at the top of the notes. But let's see, I've got angle X right here, so that's this one. If you want to, you can swoop it because the angle in question, the angle that we are talking about right here, is this one. They will always give you a reference angle. And look right here, across from the right angle, this is going to be my hypotenuse. And I also already labeled for X, this side is the opposite side. So that's why I put opposite right there. And the other side, the one that's right next to, the one that's not the hypotenuse, that's called the adjacent one. It's right next to it, touching it. Okay, anyways, for tangent, it's asked me about opposite over adjacent. So the opposite side is 26. That's why I put the 26 on top. The adjacent side is the 7. That's why I put the 7 next to the A. And 26 over 7, again, that does not reduce, so therefore there is my final answer. Sometimes they could ask you a trig ratio, and I just want you to keep in mind that you might need to find this side for a different question. Maybe if they asked you about sine or cosine, which needed the hypotenuse in its ratio, you can always find the third side of a triangle by using Pythagorean theorem, so don't forget that, okay? Let's look at number 8. I wanted to refresh your memory. You had another chapter in geometry about special right triangles. And I bet that you want to roll your eyes when I say that. But I also want to flip to the formula sheet. This is on the front page of the packet. But look, there's not very often will you use this formula sheet, but you do have it there for reference. Do you see the 30, 60, 90 triangle right here? So remember that your side ratios, your small side, your short side, which is labeled X, is the side that's across from the 30-degree angle. The long side is X root 3. That's across from the 60-degree angle. And your hypotenuse is 2X. That's just the relationship between the three sides of a 30, 60, 90 triangle. It is a special right triangle, and you have that on your formula page. So let me go back. And that is exactly why I labeled this triangle as I did. The shortest side of the triangle is the one across from the 30-degree angle, and that is why I labeled that with an X. That is directly from the formula sheet. And if I twist or turn or pivot this triangle, you still need to be able to find the short side, the hypotenuse, and the long side, because that's what they're referenced, okay? The hypotenuse here is the one obviously across from the right angle. That one's with the 2X. I labeled that 2X. And then our long side, our third side is labeled X root 3. So because I recognized this was a special right triangle, and I knew it because I had a 30-degree angle right there and a 90-degree angle there, make sure that you remember that you've got those ratios on your formula sheet. So I labeled X, 2X, X root 3. And now let's see if I can figure out what the question is, okay? What is the length of PQ? Okay, well, PQ is this. And look, I was given this side, which is 8. And I know that 8 is supposed to equal 2x, so I wrote that here. This is probably how you did these questions when you were in geometry class, is you labeled all three of the sides with x, 2x, and x root 3. And then whatever number you're given in the question, which in this case was 8, just equal it to whatever you labeled that side as. So 8 equals 2x, which means x equals 4. So now that means that this side right here is 4. Oh, snap. That's what they were asking me for, QP. Right? PQ, QP. They were asking me for X, and I figured out that X was 4. They could also ask me for PR, and I would just plug it in right there to the X root 3. Okay? I think we have another one we could try if that didn't really make a bunch of sense. Let's see. Here we go again. I have a 60-degree angle and a right angle, which means this is 30, which means again I have a 30, 60, 90 triangle here. And notice how I labeled my short side X, my hypotenuse 2X, remember that's the side that's across from the right angle, and the height here, which is X root 3. And so look, they gave me the 12. The 12 is labeled 2X, and I just wrote that equation right here, and that means that X equals 6. Okay, so that means that this part right here is 6. Now, what is the question that they're asking me about? AD. Oh, okay, because this is an equilateral triangle right here, and how do I know that? Because this is 60, this is 60, and this is 60 right here. That's an equilateral triangle, which means that this whole side is 12, this whole side is 12, this whole side is 12, but they are asking me, you guys, about AD, which is the exact same length as this, which is labeled X, which is 6. So those are two kind of challenging 30, 60, 90 questions, okay? But we have a couple more of those to practice if you would like some extra help with stuff like that or anything. But if you take anything away from this lesson, it's not very often that we talk about the formula sheet, but remember it is there and it can be helpful every once in a while, okay? Again, if you need more help with angles, triangles, Pythagorean theorem, trig, anything like that, come see us. That's what Optional Fridays are for, but hopefully you have a better understanding about these angle questions that were reviewed on this geometry lesson, okay? Thanks for watching, you guys, and we'll see you next time.